Okay, welcome to the YouTube session of Karnataka Competitive Entrance Test 2021 or 2022. In this class, we are discussing about the sequence and series, about the important as well as the basic points of the sequence and series. So, before going to the multiple choice questions, let us know the subject about the sequence and series. So before going to the topic, let us introduce our Unacademy. So Unacademy is the largest education platform. Here, all types of competitive examinations courses are available for learners by the educators. So here we have a best plan for the Karnataka. So here we have a best plan for the Karnataka CET 2021, that is 12-month plan at rupees 12,375 rupees. On average, you have to pay 1,031 rupees per month. And we have a 6-month plan at rupees 10,125 rupees. On average, you have to pay 1,688 rupees per month. And you can go with the trial offer, that is 1-month plan at rupees 2,250. And this offer will be up to 31st of December. And this offer will be up to 31st of December. And this offer is only for the new subscribers. Okay. So if you have a doubt why we have to purchase the Unacademy Plus subscription, means here by purchasing the Unacademy Plus subscription, you people will get a better opportunity that here from the educators you will get a premium content at affordable prices, and structured live courses plus dedicated live out covering sessions are also available for you people. Quizzes at the regular intervals for the self analysis, and batches for the complete preparations will be made. And keep in the mind, every month there will be a new batches for you people, and the test series for DPPS full length mock etc. with the analysis also be provided. Then you can get by the single subscription you can get the unlimited access. And one thing, to get a maximum discount on the subscription amount, you people can use the code, that is ADARSH KCET. By using this code, you can get the maximum discount for the special class as well as for the plus subscription. Okay. Then here Unacademy has been given a new opportunity for the competitive MCQ preparing students, that is free practice test for Karnataka CET. Attempt the test for free, and this program has been started from the 2nd November. Please enroll and get the more confidence on your topics which are you completed, and the test is free only. And here we are providing a best plan for KCET 2021 aspirants, that is already we mentioned the 12-month plan at rupees 12,375 and the 6-month plan at rupees 10,125. On average you have to pay 1,688 rupees. Okay. So here in a 6-month plan we complete a syllabus with doubt clearing sessions are also, and in Karnataka CET we go with the Kannada language also, there is no problem for that. And one more thing for the students, we are providing a no cost EMI facility to pay a 12-month plan or 6-month plan. So EMI, no cost EMI available on only for 6 months and above the 6-month subscription plan only. Okay, and the multiple batches launching for the every month. These are the opportunities they are an Unacademy platform has given for the aspirants of CET. So use the better opportunity by using the referral code Adarsh.B.K, or you can go with ADILIVE. Then let us start our sequence and series. So let us introduce about let us see the basic concepts of the sequence and series. So before going to the sequence and series, let us know about the concept overview. So what are the concepts we have to cover in the sequence and series? One thing, we have to cover the definition of sequence and the series. Then we have to go with the progression. In the progressions, it is classified into 3 types. One is arithmetic progression, geometric progression, harmonic progression. So these are the 3 types of progressions we have. After that, we have to discuss about the means, that is arithmetic mean, geometric mean, and the harmonic mean. These are the topics is enough for the competitive examinations. Okay. Once again, so we have to first understand what is the sequence and series definition. then we have to go with the progressions, then we have to go with the means. Okay. So let us know here the definition of sequence. So here sequence is nothing but in generally a particular order. A sequence is nothing but a particular order. A section of terms A1, A2, A3, A4 formed according to the some rule or law. It means whatever the arrangement of a numbers we have, these numbers are arranged in a particular order, then the particular order is nothing but some rule or law. Okay. The succession of terms A1, A2, A3, A4, what are the numbers we arrange in a particular order, then we have to say it is a sequence. For example, 1, 4, 9, 16, 25. Here if you observe 1, 4, 9, 16, 25, 1 can be written as 1 itself only, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25. So here we are applying a squaring of a numbers. Okay. So here we have a particular pattern of a numbers. Then here go with the second example, minus 1, plus 1, minus 1, plus 1. It means alternately we have taking a negative sign and the positive sign for the same number. This is also a particular law we call it. And observe the third example. Observe the third example, x by 1 factorial comma, x square by 2 factorial comma, x cube by 3 factorial comma, x power 4 by 4 factorial. You observe, in the numerator, for the variable we have the powers are increasing. For the denominator, we have a factorial are increasing. For example, in the first term we have x by 1 factorial, in the second term we have x square by 2 factorial, x cube by 3 factorial, x power 4 by 4 factorial. So the particular arrangement of numbers what we have with respect to a order, so that we call it as a sequence. Okay. So the number if we arrange in a particular order, for example, we say example for list A ascending orders from this number to this number, list A descending numbers, or list A only odd numbers, or list A only even numbers. So what are the numbers we are arranging? So those numbers we are arranging in a particular order, those type of numbers we call it as a sequence. And here sequence is classified again in the two types. One is a finite sequence and another one is a infinite sequence. A finite sequence is nothing but in a sequence is in a limit form, or you can go with a number of terms which are countable in a sequence is called finite sequence. In a sequence, the number of terms which are uncountable terms, then we say it is a infinite sequence. For example, here we have the first example as well as the second example. So this is the first example, second example, third example. Observe here 1, 4, 9, 16, 25. Only we have a 5 terms. So this we say it is a finite sequence. Then here minus 1 comma 1 comma minus 1 comma 1 and so on we have. So here in the second example and the third example we are uncountable of elements. So we have to say for this infinite sequence. This is the definition of a sequence. Okay. Then let us see about the series. The indicated sum of terms of a sequence in case of a finite sequence, that is A1 comma A2 comma A3 and up to AN. Then the corresponding series is A1 plus A2 plus A3 and so on up to AN is equals to summation k is equals to 1 AK, where k is equals to 1 to n. This series has a finite or limited number of terms is called a finite series. So here observe here we have a sequence that is A1 comma A2 comma A3 and so on up to AN. For a sequence, if we have a arithmetic operator between the two numbers like A1 plus A2 plus A3 plus and so on up to AN, then we say it is a series. Okay. In the sequence there are no symbols, but as in coming to the series there will be a symbol like a plus, minus or multiply or maybe a division. When we have these type of series, these type of condition, then we have to say it is a series. And one thing keep it in the mind, series are always indicated by summation AK, where K is equals to 1 to N and N belongs to a natural number. Okay, is called a finite series. Series is applied for only a finite series. Okay. So let us coming with the progressions, because as coming to the series, between the numbers we have to use the arithmetic operators, then only we have to say it is a series. With respect to the, when it is adding, we have to say it is a arithmetic progression. When they are multiplying, we have to go with the geometric progression. And when we have a reciprocal of the elements, then we have to say it is a harmonic progression. Let me discuss one by one. So arithmetic progression. So this arithmetic progression, in the short form we write it as AP. So here AP is a sequence whose terms differ by a fixed number. It means each and every number is differ by a fixed number. The fixed number is called a common difference. For example, I will go with the numberings only. 1 plus, 2 plus, 3 plus, 4 plus, and so on up to plus 100 we have. Let us assume it. Here 1 is called T1, 2 is called T2, 3 is called T3, 4 is called T4, and so on up to T100. So here the position of a number we indicate as a term number, that is term 1, and 2 term 2, 3 term 3, 4 term 4, 100 term 100th. Okay, we have to find a common difference. How to find the common difference means the difference between the two numbers, that is the T2 minus T1, T3 minus T2, T4 minus T3, T5 minus T4, T6 minus T5, in this way. Now observe the difference between the two numbers. 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1. Similarly 100 minus 99 is 1. Here the fixed number is constant for each and every number. Each and every number. So according to the definition, AP is a sequence whose terms differ by a fixed number. If I add by 1 to each and every number, then it will be get the more. For example, 1 is added to 1, we get 2, 2 is added to 1, we get 3, 3 is added to 1, we get 4, and 4 is added to 1, we get 5, and again, and so on. Here 99 is added to 1, then we get 100. This type of sequences we call it as a arithmetic progression. In this, the first number we denote it as A. The first number we denote it as A, and D is the common difference. Here common difference is nothing but the fixed number. Whatever the fixed number we have in a sequence, that fixed number we call it as a common difference. And so by using this example, we generally denote the arithmetic progression as A comma, A plus D comma, A plus 2D comma, and so on up to A plus N minus 1 into D. This is the general form of an arithmetic progression, where A is a first number, D is a common difference, and nth term of an AP is A plus N minus 1 into D. And to find the common difference, we have to go with the Tn minus 1. Okay, or else term 2 minus term 1. And one more formula we have, that is sum of first n numbers. If I add all the numbers 1 plus 2 plus 3 plus 4 and so on up to 100, what will be the answer? To find these type of results, we have to use the formula, that is Sn is equals to n by 2 a plus l. L is nothing but Tn or An, because in some of the textbook nth term is denoted as An, in some of the textbook nth term is denoted as Tn, and here the Tn is nothing but a last number, so we indicate that it is a L. Or this Sn formula is also can be written in the another form, that is Sn is equals to n by 2 into 2a plus n minus 1 into d. These are the two formulas we will use to find the sum of n terms of an AP. This is the formula we use to find the last term of the AP, and this is the formula we use to find the common difference. Always keep it in the mind. First number is a first term, that is A value. Okay, this is the arithmetic progression. And here we have some important points to remember with respect to the competitive part. Let us know here. So here nth term of an AP is the form of an plus b. An is an plus b, that is a linear expansion in n. In such case, the coefficient of n is the common difference of the AP. So if any of the equation is in the form of an plus b, this an plus b we say it is a linear expression, then the common difference will be the coefficient of n, that is a. So please make a note, this is very important point for you people. Then the second point, sum of first n terms of an AP is of the form an square plus bn. When we have of the form an square plus bn, then we have to say it is a quadratic expression. Here we have quadratic expression in n. Such case, the common difference is twice the coefficient of n square. Twice the coefficient is nothing but 2a. If it is a linear expansion, we get only the a. If we have a quadratic equation, we have to take 2a. Then nth term of the sum of two terms is Sn minus 1. This is very important. For example, we can say that T3 is equals to S3 minus S2. In general, I am giving an example because you may confuse in the n form. So I am taking here in the place of n, if I take a 3, then T3 is equals to S3 minus S2 it becomes. To find the nth term we can use this formula also, that is Cn is equals to Sn minus 1. Next we have a properties of an AP. Here, if each term of the AP is increased or decreased, multiplied or divided by the same non-zero number, this is an important thing you have to remember, then the resulting sequence is also an AP. It means here the sequence will be increasing or decreasing or multiplied or divided. Increasing means adding, decreasing means subtracting, multiply or divide by the same non-zero number, then the resulting sequence is also an arithmetic progression. For example, if we have 1 plus 2 plus 3 plus 4 plus and so on, let us assume it. I will multiply by 2 for each and every number. Then we get 2 plus 4 plus 6 plus 8 plus and so on. Then we can say this sequence is also an arithmetic progression. This is the explanation of a first point. Okay. Then generally they will ask 3 numbers in an AP. Find the first 3 numbers of an AP means we have to take from the general form, that is a minus d comma a plus d. And to find the 4 numbers in AP, we have to use a minus 3d comma a minus d comma a plus d comma a plus 3d. To find the 5 numbers in an AP, we have to take a minus 2d comma a minus d comma a plus d comma a plus 2d. And to find the 6 numbers of an AP, a minus 5d comma a minus 3d comma a minus d, and a plus d comma a plus 3d comma a plus 5d. These are the very important points. You have to keep it in the mind, because on the basis of this exam, this topic only they will ask the questions in your JEE as well as in KCET. The common difference can be 0, positive or maybe negative, because some people will, some numbers will be there for the common difference. If we subtract the greater number by minus smaller number, then we get the positive value. If we subtract a smaller number to the greater number, then we get it is a negative. So common difference may be a negative or maybe a positive, even it may be a 0 also. Then we know the nth term. Nth term is nothing but we take it as a plus n minus 1 into d. Similarly, kth term is nothing but from the last means n minus k plus 1th term from the beginning. Okay. And the sum of 2 terms of an AP equidistant from the beginning and end is constant and equal to the sum of first and last term, that is tk plus tn minus k plus 1 is equals to constant. That is, we can find the constant value by first term and the last term. Okay. Then If A, B, C are in AP, then 2B is equals to A plus C. This is the important result. We have to keep it in the mind. If A comma B comma C are in AP, then 2B is equals to A plus C. This is the important top point for the properties of an AP. Okay. Then, so let me discuss about the arithmetic progression here. Coming to the geometric progression, when we have a difference or a sum, when we have a difference or a sum, then we use the concept AP. Then we use the concept AP. Similarly, when we multiply or divide in a sequence, then we have to go with the geometric progressions. Okay. Here, geometric progressions is a sequence of non-zero number. Each of the succeeding term is equal to the preceding term. Each of the succeeding term to the preceding term multiplied by a constant. Thus, GP, the ratio of the successive terms. As coming to the AP, we are finding the difference between the two terms. But as coming to the geometric progressions, we have to take ratio between the two terms. And that ratio will be in a common. And that ratio will be in a common fixed number. That is common ratio, we call it as, of the sequence. And it is obtained by dividing any term by the immediately previous term. Therefore, so we indicate by the standard form, that is A comma, AR square, AR cube, AR power 4 and so on is a geometric progression. So as coming to the AP, just I will go with the reference. We write A comma, A plus D comma, A plus 2D comma and so on. This is a sequence of an AP. A comma, AR square comma, A cube and so on. This is the sequence in the GP. But A is a term, it is a fixed. When we go with the difference, then we say it is a common difference. When we go with the ratio, then we say it is a common ratio. Here common difference is nothing but we are taking Tn minus 1. Common ratio can be given as Tn minus 1 divided by Tn. Tn minus 1 divided by Tn. In this way we have to find the common ratio. In this way we have to find the common difference. This is the difference between the arithmetic progression as well as in the geometric progression. Then here to find the nth term of an GP, we have to use the formula, that is Tn is equals to A into R per n minus 1. This is the formula to find the nth term of the GP and sum of first n terms. So to find the sum of a geometric progression, we have to use the formula, that is Sn is equals to A into R per n minus 1 divided by R minus 1 when R is greater than 1. This is the first formula. Similarly, when R is less than 1, we have to use the formula, that is Sn is equals to A into 1 minus R per n divided by 1 minus R. These are the two formulas we have to use to find the sum of first n terms of a geometric progression. Then, when we have an infinite series for the geometric progression, then S infinity is equals to A divided by 1 minus R. Okay, sum of infinite terms of a GP can be found as Sn is equals to A by 1 minus R. So you can ask that out, sir, then what about the AP? How to find the sum of infinite of an AP? Will be a infinite itself only. There is no formula for the AP progression. This is the definition of a geometric progression as well as the nth term and the sum of terms of a geometric progression. Here we have a sum of the properties. Please follow here. Here the three consecutive terms of an GP is A by R comma A comma AR, because this is a very important thing in your concept, in the sequence and series concept. Then here we have a standard statement. If A, B, C are in GP, then we get B square is equals to AC. B square is equals to AC. Then if each term of the GP is raised to the same power, then the resulting sequence is also a GP. Okay. Then if A1, A2, comma A3 and so on up to AN is a GP of positive terms, then log A1, comma log A2, comma log AN is an AP and vice versa. Okay, if I apply a logarithm for the GP terms, then it converts to a AP or vice versa. Okay, these are the important properties of a GP. Okay, please take down take a screenshot because for the better reference for your further preparation. Next, let us discuss about the harmonic progression. A sequence is said to be a harmonic progression if the reciprocal of the terms are in AP. So the reciprocal of an AP, what we call, it is an harmonic progression. Make it as HP. The reciprocal of the arithmetic progression is called harmonic progression. The same formulas what we use that to be applied here. So in the arithmetic progression we are writing a comma a plus d comma a plus 2d we are writing. But here according to the definition the reciprocal of an arithmetic progression is an harmonic progression. So generally we write it as 1 by a comma 1 by a plus d comma 1 by a plus 2d and so on up to 1 divided by a plus n minus 1 into d. So this is a standard form of an harmonic progression or general form of a harmonic progression. To find the nth term, we have to use the same formula, that is Tn is equals to a plus n minus 1 into d. Okay, whatever the value we get, we have to write into the reciprocal form, that we call it as a harmonic progression. Then here we have one of the important result on the harmonic progression, that is if A, B, C are in the HP, then B is equals to 2AC by A plus C. This is the one formula, or you can go with A by C is equals to A minus B divided by B minus C. Okay, this is the standard result. You have to keep it in the mind because these results will help to solve a problem into a shortcut method. So then here let us discuss about the mean. Okay, we know usually mean formula. What we would say mean? The total number of terms divided, the number of terms divided by total number of terms, that we call it as the mean. Okay, or average. So mean means we have to add the first number and the last number we have to divide by 2. Then we say it is a arithmetic mean. Similarly, AM is nothing but arithmetic mean, that is given as A plus B divided by 2. Geometric mean, here they given as root of AB. And harmonic mean they have given as 2AB divided by A plus B. Already the proof, all the things you studied in the 11th standard. Okay, just you keep the formula in your mind because it is useful to solve the problems in a competitive examinations. Then here we have one more, the standard result, that is sum of n terms of an arithmetico-geometrico series. It means the combination of arithmetic series as well as the geometric series. We have a standard result, that is the combination of arithmetic and geometric series can be written as a plus d r plus a plus 2d r square plus a plus n minus 1 into d into r power n minus 1. It means the product of AP corresponding AP terms and the geometric terms into a series form. Then we say it is a arithmetic geometric series. To find the formula, here we have a SN formula to find the arithmetic geometric series, that is SN is equals to A divided by 1 minus R plus D into R, 1 minus R power n minus 1 divided by 1 minus R square minus A plus n minus 1 into D divided by 1 minus R into R power n, where R should not be equals to 1. If R is equals to 1, what happens? The sequence does not exist because it forms the indeterminate form. And to find the sum to infinity, we have to use this formula, that is S infinity is equals to A by 1 minus R plus dr by 1 minus R whole square. This is the formula to use sum to infinity. Then here we have a standard result. Okay, this one we have to always keep it in the mind. Summation R into, okay, here I will go with n. Okay, n into n plus 1 divided by 2. This we say sum of first n natural numbers. Okay, Then sum of squares of the first n natural numbers, that is n into n plus 1 into 2n plus 1 divided by 6. These are the standard forms we discussed in the chapter mathematical induction. And summation r cube, it means cube of first n natural numbers. We have n square into n plus 1 whole square divided by 4. Then r power 4, we have to write n by 30 into n plus 1 into 2n plus 1 into 3n square plus 3n minus 1. This is a standard form of fourth power of a first n natural numbers. Then sum of odd numbers is n square. 2r minus 1 is the standard form of an odd number. So here we have a summation symbol. So we have to say sum of odd numbers is equals to n square. Similarly, sum of even numbers is equals to n into n plus 1. And keep it down here. If keep it down it as a note here. If nth term of a sequence in the given Tn is equals to an cube plus bn cube plus cn plus d, where here a, b, c, d are the constants, then we have to go with the method summation n cube plus summation n square plus summation n plus summation 1, we get it. So here the coefficient will be a, b, c, d. Here we represented, we have to write in this format. For any equations, if we apply the summation, that is sum of n terms, then we have to convert into the form. So summation n cube means here we have a formula, that is c part. Summation n square is nothing but b formula. Summation cn is nothing but a formula. Summation d is nothing but it is a constant, because how many constants you can take it, we get the same constant itself only. Generally we say summation k is equals to n, kn. Summation n is equals to kn, we say it. Okay, because summation 1 is n, because summation 1 is nothing but 1 plus 1 plus 1 plus and so on up to 1 plus and so on. How many times 1 is adding? N times 1 is adding. So n into 1 we get n. So similarly we say summation k is equals to kn and summation 1 is equals to n. These are the important results of a sequence and series, and these are the basic concepts. So please be perfect on these basic concepts, then we can move for the multiple choice questions very easily. Let me discuss in the next session the multiple choice on the sequence and series in a shortcut trick. Here we have plenty of shortcut tricks only. Okay, please don't miss the session and inform to your friends also to watch the session, because you will learn how to solve a sequence and series in a shortcut method. Okay, fine. Thank you.